Wi-Fi accessible?
Keep Austin hacking.
Oh.
The Capital Factory one.
Should it be Capital Factory Guest or Capital Factory?
Capital Factory Guest, you need one of those pieces of paper with the temporary password. Capital Factory itself is keep Austin hacking. They have not changed it in the 6 years I've been coming here.
Sound like a good security practice.
Well, they only give that one supposedly to the speakers, but since anyone can speak.
Thank you.
Okay, so it's almost time to start. Hey, I'm Luke Imhoff. I run the meetup. Jim Freeze, the guy that runs the ElixirConf, started the meetup long ago. But I mostly run it now. So we'll go around the room. Say who you are. Are you using Elixir in production? Are you looking for Elixir work? Is the company you work for hiring Elixir developers? Normal stuff.
So I'm Samir, I'm relatively new to Austin. I used to be here a long time ago, but I'm just here to learn. Did Erlang long time ago, so just on the fence right now. Yeah, should I like dive into FB or not? So just trying to get some.
You wait long enough, the imperative languages will catch up. So
Pardon?
if you wait long enough, the imperative languages will catch up, and they'll have FP features. So.
Well, I mean, my favorite language, Python, actually has
Python's...
a lot of them, but it doesn't have like tail recursion. So
yeah.
That to me is like the thing which distinguishes the real ones from the. So I like those features, but I'm honestly here just to like find out something else. Also, like, is pattern matching like anything more than a glorified case statement, or does it like open your consciousness to some wider concepts or something, which frankly I don't know if I've found that answer yet, so maybe that's
Artie?
I'm Artie. I work at Sparefoot across the street. We do not use any Elixir or Erlang. It's a shame. I try to get people to think functionally, and occasionally I succeed for a moment or two, but not often. We're not hiring anybody for Elixir. Probably not.
Yeah, I do have to say, I've taken my Elixir back to my Ruby, and like keeping our invoicing and cost estimating code functional has made it way easier to add new business rules. Because I don't have to worry that I accidentally wrote to a cache. You know, and a cache is any class instance variable. And so you don't have to worry about that, and it's very easy to rearrange the rule order because you know exactly what you're passing and you know what you depend on, so it's very nice.
I'm Joel. I work for a company called Magic Leap, augmented reality stuff. I live in Elixir all day long.
Wait, the elephant demo then? Okay.
That's one of our things, yeah. You're talking about the elephant in the hands thing? Yeah, that's one of them. So yeah, I work on the services layer for all that stuff. And like I said, it's all Elixir, microservices, fun stuff. So it's a kick.
Are you using nerves for the actual hardware part in like the backpack and headset, or is that has to be too fast, so it has to be like C and shit like that?
That's the device that is all embedded C.
Okay.
I'm Tony. I work for DJO Global, an orthopedics racing company. We've got some Elixir projects that help out a little bit with those, but you know, I'm a Ruby guy for most of what I do. We're hiring Rubyists, but we're not hiring any Elixir folks right now.
Hi, I'm Dan. I work for a small startup here called Atmosphere. They mainly use Grails framework there. Just thought I look around, saw some tutorial on Elixir. Thought it looked kind of cool, so I probably want to learn a lot more about it. So that's why I'm here. And we're not hiring any Elixir. Well, I mean, if there's like job for Elixir, how's the job market like for Elixir developer in Austin?
I mean, not as good as Ruby because Elixir is smaller than Ruby, and Ruby's a small community. So like, when I was just the Rubyist, I thought Ruby was big because it was easy to get a job. But Ruby is tiny, tiny, tiny compared to C, Java, and PHP. PHP is 3% of the market, of the web market. Like, it's not just WordPress. It's like in general, PHP dominates by a lot, and so Ruby is a very tiny, I think like single-digit percentage. And so, so I maintain the IntelliJ Elixir plugin, and Josh Adams does the yearly survey where he found out that my plugin is 8% of the market for people that respond to the survey. So that 8% times the download numbers I have means the current number of Elixir developers is between 50,000 and like 100,000. But jobs, there's like 3 job boards. You can see how many jobs there are. There are jobs, but a lot of them are they're much more worldwide distributed, so they might not pay well for what you're used to here in Austin, so it might not be worth taking. But there are jobs everywhere. And I mean, Jim Fries's son works for that Vutu, the LinkedIn competitor in Germany. So it's possible as an Elixir developer to get a job in another market, and it'll be remote. Because they're more, Erlang and Elixir companies are more willing to have remote people because they know the market's so small for developers.
I mean, so you've been developing in Elixir for a while. It's like, what's
2.5
the
years.
adoption rate like? Is it growing fast?
Yes, it's definitely accelerating. So my numbers, like there was a huge bump from 4,000 users to 8,000 users of my plugin at the end of last year for I don't know what reason. There just was. And so there seems to be a massive uptick. And you can see the numbers from Josh's survey year to year. It's growing. Same thing with the conferences. They're growing very fast. It's hard to compare to the Ruby numbers because remember, Ruby started as a community much earlier. Programming languages having communities around them was a much different thing. You know, like Python started in the 90s when it was stuff on news groups, on Usenix. that you talked about, you didn't meet in person at like a meetup or even at a conference. And so like to compare the numbers at the conferences for ElixirConf, which has grown faster than Jim Freeze's Ruby meetups, are kind of hard to do that comparison because people are just more like companies send you to conferences now, or people go to conferences to, like that's how you learn the kind of stuff about a language community. And so it's hard to compare those numbers. But the growth has been faster.
I mean, a few years ago, I remember Ruby on Rails was really hot, and it's kind of fizzled out after a while.
I think it's just getting mature, so it's not as sexy. I don't think it's fizzling out. I mean, personally, I do have worries. Like so like I was in the Ruby community, I was big on Ruby. I was like, you know the details of the VM. But when I came up for air and like looked at the other communities, so it wasn't just like Elixir, following Scala, Clojure, C++, JavaScript, and Python, they're all making progress either towards functional or asynchronous stuff. So like C# and Python both have async await. Python in the 3.5 line, of course. So Python has the problem that some people don't want to upgrade from 2 because they think it'll be hard, which makes Guido sad. Guido's the benevolent taker of Python. Like it literally makes him sad. Someone asked him at Erlang Factory like 2014, and like that's what he's sad about is people want to upgrade because 3.5 is awesome, and 3.6 is even better because they actually have a static type checker in MyPy that's equivalent to kind of like Dialyzer for Erlang now, and PyPy, their like JITted compiler is really good, but right now Ruby's outlook for MRI at least is by 2020 Ruby 3 should be out, and there might be some way to make it scale better to multi-core, but they don't really have a fixed pathway. They're experimenting still. While like every version of JavaScript gets async and await and generators, and they're unifying observables and events and all these other things. Like all the other language communities are pushing forward their language to a more functional style that will work better in a multi-core future, and Ruby to me feels left behind when I look at those other communities. Even C++, you know, crazy mutable buffers, they have things in the working groups for data flow languages where almost like Haskell, where you would say like, here's all my data that's connected, and it would figure out how to run the code as parallel as possible for you. Like those are the sort of talks at CPPCon, and I'm just not seeing that from Ruby. And so Ruby will be there, it'll still work, it has a huge community, you know, the gems, everything else, still make it faster to, because there's so many gems to do things for each company. A lot of companies still make a gem first before they make any package for any other thing. Maybe they make a node package first. It still has that like early development prototyping advantage of you don't have to write as much code. But the shift now is like you have to be okay with like you're going to throw that code away. Now probably people should have been used to that already because you shouldn't plan for scale when you start a startup. Like we shouldn't make this have so much infrastructure that it's going to work when it gets super popular, because you're probably going to make the wrong business decisions in your code. But like it's less likely that you can stick with Ruby, and you have to be okay with that now. But like there's nothing wrong with staying in Ruby. It's just it's not as sexy anymore. But like you have to be okay with that. There's still a lot of conveniences with how such a good community Ruby has, with like being able to Google everything, being able to look on Stack Overflow. Like that is really nice. It used to be that programming communities did not have that. It was you found a forum, you found a specific expert on that forum that knew how to answer your question. Ruby did those changes. The fact that like your language needs to have a package manager and have a website where you can look up the packages, like Ruby gems, that was the thing Ruby did. CPAN existed for Perl, but that was more almost like the Usenix style of like, it was this server somewhere that you had to access, like it wasn't as convenient as Ruby gems is for Ruby. And Elixir benefited from those things of like, I mean, those were some of the tools why Elixir was an improvement over Erlang, was that it had that mentality for community and for tooling that came from Ruby, you know, and even more so that like every mixed thing is going to be a mixed project. While with Ruby, like the gem file for bundler is still like an add-on. While in mix, like you have a mixed project, it is always a mixed project. It'd be weird not to have a mixed project in Elixir. And so like we are standing on the shoulders of what we learned from the Ruby community. It's just, it's not moving fast enough to be multi-core, to work for multi-core. Now, that being said, if you're okay not using MRI and you're okay with using JRuby, the stuff that Sun's doing in about 3 years, well, I think 2019, so like 2 years now, they're doing stuff to make it so that, in theory, they'll be able to ahead of time compile the classes that you need to boot the JVM. So that problem with JRuby where like it takes a while to boot the JVM, so that because like the JIT adds overhead to like be able to make your class JITable, it has an overhead that will maybe get out of the way, and it won't be a pain to develop on JRuby. So the problem with JRuby is like you can't do command line tools because there's that overhead of starting everything up and loading all the classes, and then actually running the Ruby parts once the Java classes are loaded. And like the stuff that Sun is working on, like that is all because JRuby got popular. Like when Oracle bought Sun, everyone thought Java was going to waste away, and it was just a way to write interface code for Oracle DB. And then like JRuby got popular, and like Invoke Dynamic is there because of JRuby, but now all the other dynamic languages use it. And like the JVM under Oracle is being pushed because of the needs of JRuby. So there's still things happening. It's just that the default VM of MRI seems to not be progressing as fast as would be helpful for multi-core.
Is that because of GIL or just async?
I'm not really sure. Like GIL, yeah, is a huge problem. So even Python for 3.5 had they had a proposal to have their subinterpreters, which Python.RB supported for. I think it was both a safety mechanism and a way to do like having scripting engines inside your overall Python program that were kind of isolated. Whereas they were going to make that almost what the Ruby proposal for guilds are, where like that subinterpreter would work like an actor, and you'd message pass to it. And it didn't get in, but like if they could just spawn a bunch of subinterpreters, they would have had an actor model built into the language. But they're going more the approach of like the C# way of we're going to have async and await and have the VM manage for you. So if you do async and await, you no longer care how the asynchrony is happening, it just happens for you. And so like that's the approach that C# and Python are going right now. And like 3.6, the big thing was like they allowed async inside of a for comprehension, which is somewhat what JavaScript is doing, where like you can have async generators now in the newer versions of JavaScript. So a bunch of imperative languages are going that way, where we're like, you're going to write these little tiny snippets of code, and instead of having to do manual callbacks, you'll have these keywords async and await, and we'll manage that for you under the covers. Any other questions before we start? Oh, and while I'm talking, since this is me giving it and it's not that prepared of a talk, if you have any questions about what's on the slide or a question about pattern matching, I've done this thing, I don't know how to do this thing, ask it right away, interrupt, it does not matter. But, don't just raise your hand because I might not be looking at you. So make noise or something. Okay, so as I said before, I'm Luke Imhoff. I'm chronic death just about everywhere. I maintain the IntelliJ Elixir plugin if you have questions about that. I'm on the Elixir Slack. Anyone can contact me there by name, or in the Austin room I'll get an alert. Unlike imperative languages like Ruby, Python, PHP, just about everything most of us were used to before coming to functional programming, where equals is used for assignment, equals in Elixir is referred to as the match operator because it tries to match the left and right-hand side. But there's a left bias to the match operator. New variables can only be defined, and previously defined variables can only be rebound when they're the left operator. So it looks a lot like assignment for rebinding purposes. The simplest way to use pattern matching is destructuring, which you're probably used to if you use modern JavaScript, or if you've ever had a return value of a list in Ruby, something like that. So you can match each element of a tuple or each element of a list to variables on the right. In Ruby, you just remove the square brace and just have the commas there, and you could do the same thing in Ruby. So in this case, in both cases here, A is bound to 1 and B is bound to 2. In addition to one-to-one matching that's shared with tuples, lists can also mix in the pipe operator, which is used to separate the head from the tail. This is possible because this is fast because the Elixir lists are linked lists. So what you're actually doing is you're looking at the console and you're like, here's the data element, and this other part I'm going to look at where the pointer's pointing and grab that as my tail. Each list can be broken up into linked list representations by nesting the tail. So as you can see, the stuff that just appeared is the expanded form of the list. Unlike lists like Clojure or Scheme or Haskell, where the last element of link is nil, in Elixir and Erlang, the last element is an empty list. Because the empty list indicates the end of a list, it itself is special and cannot match the generic pattern of header tails, so you get a match error. Unlike tuples and lists, which match all elements exactly when using commas, for maps, only the listed keys need a match. So both examples match and both leave A bound to 1 and B bound to 2. The reason why the maps don't require matching is because maps were added to Erlang and thereby Elixir as a response to the problem of adding fields to records, which are just tagged tuples. So they have their name as the first element of the tuple and then all their fields afterwards with special parse transforms in Erlang to access those offsets by name. When adding or changing a field in a record, all the use sites needed to adjust, but with maps, only the places that care about the new keys need to be checked. In Erlang 19, Dialyzer, the type checker for Erlang, was improved, so that one could differentiate between required and optional keys in a map. For Elixir, optional and required keys are marked with pseudo functions optional and required around the value or type of key. In Erlang, it's actually whether you do Pascal style colon equals or you do the association arrow, I think. Map types, just like maps themselves, can use either JSON style atom keys or association operator or the fat arrow to associate the keys with the value. For types, any and term are interchangeable, but I try to use any for when I don't care and term for when I do. I'll use the value, but I can't describe the specific type. A word of caution, don't go around adding optional any maps associated to any, to all your map types. Not allowing arbitrary optional keys can stop your API users, including yourself, from passing options that do nothing, and this includes typos. So here I use this spec to define the argument types and the return types for the create factory once. So this is sort of like a factory grow call, but I'm doing it set up to do over RPC. So this way I'm saying which keys are required and which ones are optional. And this actually was able to catch an error. On the bottom, I don't know if you can spot it, but there is a typo. Can anyone spot the typo?
10 out.
Yeah. But that code sat there for like 2 months until I did the upgrade to Erlang 19. And then it caught it and explained why our tests were flaky. Because that timeout was important to be able to have a bunch of background working happening in the RPC call that we were calling on the Ruby server to get done in time. And so as soon as I had that set up and running on Erlang 19.1, because 19 itself had a bug in it that I found, it caught the timeout, and it was amazing. It was awesome. Structs are built on top of maps. They have defined sets of keys and a hidden key, double underscore struct, double underscore, pointing to the alias for the module with the def struct in it. So here, double underscore struct would be Alembic document. Matching structs behave as if the defaults aren't there when matching on the right. So even though in 2, the data value should be default on set, on left it will still match the foo value on the right and allows errors to be bound, but the default can still be pulled out of a variable in 3. As shown in 4, all the struct pattern cares about is that the hidden double underscore struct double underscore key matches. If you want to match a specific struct, there's no guard function though, such as isStruct, the way there is isMap. This is because the is functions are all inlined by the compiler and defined by Erlang. And only certain ones can be used because they must be pure functions, and there's no purity checker in Erlang, so it can only trust the ones that are predefined. Structs don't exist in Erlang, so no isStruct guard was ever defined as a macro. For patterns, there's 2 ways to specify it accepts any structs, but not map. Either make the name of the struct a don't care using the underscore in the first bullet point, or do the more explicit form of that by using map syntax to show the double underscore, struct double underscore, has a key has a value of don't care, so that the key is required, which shouldn't be there in maps. I would say there's not really a settled style on this in the Elixir community. Some people really don't like one because it's very easy to miss, I guess. But I like it because it makes me think, oh, it's a struct, as opposed to having to scan for, oh, there's that special key that means struct. I didn't include in the slides, but it's actually possible, kind of indicated by this, that underscore can also be a variable. So you can do have a function that takes a struct, and the struct is always a module name, so it's like %user and then curly braces. That's the user struct. You're accessing it. So you can do %module curly braces, and then you can do a guard of win module in, and then you give it a list of a bunch of names. So you can say user, profile, address, and this is a way to do all those listed out longhand in separate clauses all at once, which can be great if like what this clause has to do is all the same. No matter whether there's a user, profile, address, you call the same function. So that way you're not repeating the same code for every single struct separately. Many imperative languages, such as Ruby, Python, JavaScript, have destructuring now, and even have a splat operator for variable length destructuring. Java even has a splat operator, but it's mostly for accepting arguments like var args. Elixir has this too, and the macro is actually called destructure, but I haven't seen it used outside the standard library, where it's used to match variable length lists returned by regex run, such as in parse version, URL parse, and URI split authority. I'm personally more partial to named groups because I find it makes regular expressions easier to read, so I don't think I'd ever use destructure in this way, but the standard library does. In addition to destructuring for shapes, pattern matching can also destructure for a given value, which can function as an inline assert. This is most common when checking that something succeeded or failed using the ubiquitous OK and error tuples, the maybe type of the Erlang Elixir ecosystem. The caret used in example 2 is referred to as the pin operator because it pins the value of the already bound variable instead of rebinding the variable to the new value. The pin operator is not needed in Erlang because you can only bind once in Erlang. In 2, we're getting the checking that we're not changing the value returned by should be unchanged when maybe changes is called by asserting that the value in before must be returned again by the second call that should be unchanged. In 3, we're doing something new here. We're using the same variable a twice to say that both elements of the tuple must be the same 3. When a variable is used more than once in a single match operation, the pin operator is not used in later use of the variable. Instead, you should think of all the places that the variables occur in the pattern being matched simultaneously. So there's no way to rebind to a later value. All places must succeed or no places succeed. This is actually a really nice way for function arguments to check that like a user is authorized, because you're like, am I allowed to see a user? So like, you could do allowed and you can just say that A is a user. And so this user, has the ID filled in, but you don't have to include that in the pattern, because all you're going to say is like, and this is true. So you can be like, you're allowed to see yourself. It's that easy because you're saying this is the same object, the same structure. From the examples so far, the experience you may have in other languages, it may not be obvious, but you can actually nest match operations So you can both destructure value and capture the entire value in a variable. I find this most useful when your current function needs to check the internals of the function and then pass along that variable to the next function you're going to call. The most common case would be destructuring a gen server state and then returning the state because that's how most gen server calls work. So we do all this work on the internals of the state, and then I update the state, and then I return the state at the end. So I'm using both the state and the internals of the state, such as the channel, ecto schema module by type, and request by correlation ID. And then in the case statement, you can see where I'm capturing the entire request struct, the client request struct, in the request variable, but then pulling out the from so that I can both work with the request in the client request to meta call, but also use the from for the gen server reply without having to match it once and then have another line to pull out the internals. The left stab is used for both for and with. In for, it is used between the pattern and the generator. In one, only those maybes that are errors will be passed to the do block, and so it only accumulates error reasons even if there are OK tuples in there. In with, it is used between pattern and function calls for that step. In two, maybe must return OK tuple or the do block won't be executed. The match operator equals in the two forms of the left stab are a way of sequencing computation. All three try to first perform a match, but what they do when the match fails differs. Equals will fail the block and raise a match error. For skips that value from the generator and goes to the next value from the generator. With returns the unmatched value or passes it to the else clause if you use that with your withs. These are all monadic operations, as monads are a way of sequencing and composing computation. It's a way of thinking of like, you have a semicolon like in C, and what do you do next? And so these alternatives are what do you do next. For running the call again, and with skipping to the else or end can lead to bugs in some situations, such as when you're confused about what pattern for the success looks like. When matching OK tuples, if you also pattern match the internals of the value, such as here we're matching for users, and the format changes, say to profiles, you end up taking the alternative path when what you actually expected was an error. If you're unsure on the type, such here if maybe records was coming from another part of your system or it's controlled by user input, then using the format in B, where the allowed patterns are spelled out explicitly, can be safer as it will raise a match error, while in A it will silently give you empty records when the actual problem is that you've started returning a new type. This has actually happened in our code before, where we changed the type or we moved to a different namespace, and so like the actual full name of the struct changed, and we weren't getting any results back. And like you read the code, you're like, why doesn't it work? And it's because our OK tuple was still there, but the internals of the OK tuple had changed, and it can be really hard to track down because for and with will just kind of let it, and with especially will just let that value fall out as like an error state, even though it's an OK tuple. To denest withs, you can actually have a clause in a with not use left stab. You can actually embed a normal equals match into the clauses. Here's the third clause of the bottom with, so that you don't have to nest your withs together. And this can be used when you don't actually care of the format, you just want a new local variable to bind the result to. You can also do this if you're going to use the temporary result more than once, but I'm not doing that here. In more functional languages like OCaml or Haskell, the plain equals kind of with would be sort of like a let statement of like you can't just define a local variable, you have to have a nested scope for it. And so Dave Thomas actually uses with that way in some of his code examples. With clauses don't need to match the success pattern. They don't have to just match OK tuples. They don't have to just match you got a value back. It is perfectly okay to match error tuples and nils. And so in my Calcinator library, sometimes I match the error tuples because I want to take the error from the underlying code I'm calling and reformat to add extra state. So when I call resource module get, it doesn't know about the parameters. So it doesn't know the ID key in params. But I know that because I'm calling it, so I'm able to repackage the error to make it better for my caller. This is somewhat analogous to in Java where you'd catch an exception and then stick it as your cause when you rethrow. Case, although a special form macro, still behaves like a normal macro in that it's a call, so you can pipe to it. So here a case, instead of actually having an explicit argument, is being piped to. So that first argument for case is not a keyword. It is not a special construct in the language. It is a special form only in the sense that there's no way to redefine it, but it still acts as a call, which means it has a first argument, and that means the piping operator works to pipe into it. So it's actually possible to put a case way on the end. You can actually have more than one case. The code gets kind of unreadable, and not everyone likes this format, but it works sometimes when you when you need too many locals in your case to like make it another function call, or if it just makes the code more readable to have that case at the end. A lot of times I do this at the end to do a check on function calls I'm calling it from other parts of my system. So here I'm making sure that I only get back OK tuples or I get back errors on that attribute. And so I'm explicitly want to get a match error on this case, or a clause case error, if for some reason I get a new type of error message that I wasn't expecting. And so this is a check so that those errors don't percolate through and give me an error that I can't reformat correctly. Recursive calls to the same function can make it hard to debug which specific pattern is matching each call. I mean, the most obvious example of this is any list manipulation function where you have both the tail case and the other cases, but you can have recursive function calls that have a bunch of different cases. And it can be hard to figure out by looking at each piece of data what is happening. So the Erlang Standard Library actually comes with a module called dbg, debug, where you can set up tracers. So you can do debug. So the problem with this module is everything is super cryptic. I mean, this is one of the shortfalls of Erlang, is that a lot of it's really cryptic and the documentation ain't great. So like I just kind of have this in my notes of this is what you do. The Erlang and Anger book also shows how with Recon how some of this stuff works, and if you use Early Burly, you can do this graphically, so you don't have to know all these patterns. So debug, I don't know what the P part means, but I know if you say P all and then Cs, you're going to look at all calls in the processes. Then TP in my mind is trace point. I don't know if that's correct. Is I'm going to trace a module, a function in that module, and X stands for execution, which means the arguments that return values. So what you end up getting is like, you get what you called the function with, unfortunately in Erlang terms, so you have to know what like a struct looks like, what a map, how a struct looks like a map in Erlang to read it. So that's one of the downsides. I think Early Burly has a mode to make it look like Elixir for you, but I'm not sure. But so this is really great because in this specific case, can-to-can is our protocol for doing authorization. So a bunch of our can calls call other can calls. So like, you know, I can see a job if I'm assigned to that job, and I'm assigned to that job if I'm in a certain state. So like there's a bunch of can calls over and over again recursing down the structure to be like, I can see the overall structure if I can see a piece of that structure. Or I can see this piece of the structure if I can see the overall structure. And so it's looping over and over again. And so being able to trace is nice to see the decision-making process of that recursive calling. But sometimes debugging like that isn't enough. Sometimes there's just, with the struct, with all the nesting, it's just way too hard to read all that and be like, that's the problem buried in that nested struct. So sometimes you have to worry more about readability. So you need to balance having to name all your functions and giving them clear names that make sense in isolation, and repeating a bunch of patterns over and over again. So if I have some nested value deeply nested inside of a bunch of structs or inside of a list, I need to dig in and get that and repeat that pattern to get to that element over and over again. So more names are easier to debug because when you're reading the code, you're going to be like, oh, this function is called in only these two places. So I know if I call this function, this is called here, as opposed to a clause where you might be completely off on which clause you called in the same function with the same name. So the more ones are easier to do, but you hit the two problems in computer science, naming things. And so, like, sometimes coming up with a really clear name that's different, that everyone else will be able to read, and like you will be able to read months later is hard. So sometimes not having to come up with a new name is a nice reason why you have a bunch of clauses grouped together and just use pattern matching.
I, J, and K.
Yeah. But like it is always a balancing act back and forth of what actually works in practice. There are no hard and fast rules. It's what can you keep in your head, what is readable. So let's look at a specific case. So this is really tiny, you're not supposed to read it, that's the point. So last week I was trying to figure out why an interpreter couldn't view their own job assignments and the jobs and job series associated with them. The rules for when a job assignment can be shown to a user's profile are complex. It depends on both the job assignment state, the job state, and sometimes the interpreters can see other interpreters' job assignments so that they know who they're working with. But all that's really long. It's 7 clauses in the code. It's way too much to fit on the screen, even at full size. Maybe a 27-inch screen on the side you build a CETL, but like it definitely blows the mental limit of someone to keep it in their head of like, all this is going to happen when I'm trying to figure out, can I show this job assignment to the user? So when you have recursive calls, you're going to have to start matching explicitly on bad input, because this can call can a profile show a job assignment, but there's also can it show a job. So you need to match on the bad cases, and for bad inputs, I mean not like the user should not be able to see bad inputs. I mean that struct doesn't have enough data for me to make a decision. So I have 3 clauses here where I'm looking at the internals of the job assignment going, well, this could never happen in the real system, so I must have forgotten to load it from the database, or from an RPC call in this case. And so I'm explicitly using argument error. It is okay to raise argument error in Elixir. You don't have to just depend on match errors. Match errors should be more like, I never meant to support this input. If you get this input and you want a clear error message, use raise argument error and say why it's wrong to help yourself. Like these errors are because I specifically kept screwing up. So this is all to help me and everyone else on the team, hopefully. So this could happen if you forget an ecto query preload or an ecto repo preload, and your struct is just stuck with ecto association not loaded. And you don't want that to fall through as it's not authorized, because it's actually you can't make the decision whether you're authorized. Every clause in a function definition is a new branch. We like pattern matching in function clauses because it allows us to flatten those nested branches. But in this code, it's obscure what the business logic is. That needs to be checked to ensure unauthorized records aren't being shown. Like, this is again one of those slides where it's hard to read to emphasize how this is complex. So we want more explicit business rules. So we start at the first entry point to a job assignment. We pull off some bad errors, but then we start breaking down right away to, okay, if the ID matches, then I'm trying to show my own record. But if it doesn't, then I'm trying to show someone else's record. And so right there now, we can agree on that name when we're trying to audit with like the non-programmers. Like, is this how we want this to work as a business rule? We can fork like showing other people's records and showing our own records. And then when we go down to the next call, we're peeling off those bad inputs and inlining them, and then calling with job to be like, okay, we have that job. But additionally, we don't want to repeat this pattern of the job as part of the job assignment, because then this is a bug if we copy this wrong in the next section. So we pull it out, already pulled out as another parameter to the function, so that we don't have to do this pattern match again. Not because it's slower, because it's not much of a slowness for the compiler to rerun that match. In certain cases, it would actually optimize to know it's the same pattern on the next call and do a forking thing. It's mostly for you as a user to not make the mistake of copying this pattern wrong. And so this makes it much more precise of what are we doing now? We're caring about what's in the job. And so sometimes it pays to not have the flat, have it flat, but have names so that you can name those decision points in your business rules. Okay, that's all I got for slides so far, so let's go to questions.
I don't think there's any good answer to this, but are there any good practices when you should decide that, yeah, this is too, you know, unreadable versus...
So this specific case was, I was working, so we had jobs, and then we added that jobs could be in a series of jobs. And we couldn't figure out why, I couldn't figure out why it wasn't working. It was just like looking at this code and being like, if I had to read the code and reconstruct the branching pattern in my head over and over again, it wasn't worth it. It wasn't worth having that flat code and not having to come up with a name for that next decision point, because I had to reconstruct in my head each time I read the rules of like, okay, this. While can show own is like, okay, I know I'm an authorized user now, so like I should only care about this branch. So it's purely experimental of like, you know, you write it one way and you're like, it's great, it's flat, I didn't have to come up with new names. In general, I would say is anytime you have a outer scoped pattern that you have to repeat in the next clause and then like expand on it, you probably shouldn't do that. Not because it's not going to be fast, but just because you as a programmer have to keep those two in sync. And so if it turns out like the first pattern needs to be updated to like add a new attribute inside the struct that has to be checked, you have to remember in the next clause to add that too, or the meaning of that clause changes because you're no longer checking that part.
Cool.
Now, I realize I didn't include this in here, but who's using with right now in their code? Anyone using with? Okay. So does everyone know what with does? Okay. So we'll go over why with was added to the language. So if you have a call that could fail, the normal way of doing it is you have OK, value is the good kind, and error with some reason is the failure case. In a lot of languages with name types, like Rust or Haskell, this is called the maybe type, because maybe it's going to work, maybe it's going to blow up. So you have these two values that some function could do it. So you could do, oh yeah, that's right, that's an either type. The maybe type is, it might not contain anything, it's more like nil. So you have do it, it could call. So if you have these errors and then you have another function that might error, and you have another function that might error, there's no early return in Elixir. You can't return from the middle of a function and be like, I don't care about the rest of that code. So what you had to do was you do case and you call the first function and then you'd need a case and you'd call the second function on that value and you'd have a do and you'd have a OK. And so on and so forth. You keep having to nest this stuff over and over again. And in each case, you're like, okay, I get this error. There's a reason. And now I just have to, I'm going to return it anyway. With the reason. Oh wait, this one can also error, so I'm going to do error reason. Oh, well, I guess I'll just return that because I don't have anything better to say about it. Reason. And I mean, you could be clever and do like this equals E, and then return E, so you don't have to write out the tuple again. That works. But you're still like, every case you're like, each case of the either, do like, okay, we take okay, call the next thing, then call the next thing on okay, but otherwise always return the error. So super nested. The other way to do it, instead of the super nested way, is you would have to do a bunch of ifs to like block out the next section. So like that really is the best way. Or having a bunch, every one of these cases has to be a name function with a bunch of clauses. So you could do this all with piping. So you could say, first, pipes the second, pipes the third. And you're like, wow, that's really clean. I can just pipe it, that's great. But every single one of those functions needs to handle the return type from the previous one. So second has to have two clauses. It has to have an OK clause, where it takes in a value, and then calls third with the unpack value, does some work on it or whatever. And then it also needs a clause where it does where it takes the error and the reason, finds it, and just passes it along as E. So this one doesn't call it because it's like short-circuiting it. It's not going to call the next part. So this value, we would do some work on it, and it would do a value. This one returns E. So it does some work, return the next one. So you have to keep matching over and over again. Okay, error, okay, error, okay, error. I have code like this, or I did anyway before with came out. And so the problem with this is, first, you could just have it take in a number like 1. But all the calls afterwards have to know that they're actually taking in the either monad. Like, so that's kind of annoying. Like there's this first is special. All these other ones you almost have to make private functions because they don't make sense in isolation. You can't test them in isolation because they depend on the return format of the other one, not just the value. And if you watch any like talks in Calcinator 3, you can see like this kind of doesn't, it's not right for the types to work this way. And it's just really annoying to maintain the code, especially if you're like, I'm going to put stuff here, or I'm going to change which one's last. Like it screws everything up. It makes it really annoying to refactor code. So what, more stuff. Okay. So we have piping, we had the nested case, both of them not great for different reasons. But this pattern of having some sort of either monad or having this success and a bunch of error cases happens a lot. The OK error tuple is huge in Erlang. It's used a lot in Elixir. There's some cases where it's more of the implied maybe monad of like nil or the value with no OK at all, which is actually way more annoying to match. So this came up so often that they're like, well, let's come up with this with syntax. So we say, okay, value. We take first. Then, this means, remember from the talk, if this match succeeds, go on. So then we're like, okay. And then finally, for third, we're not going to call anything else, so we don't actually care. So we can just call third in the body and give it value 2. And it'll be done. So no super deep nesting and no needing first and second, only have to care about values. They do have to return the monad, but they don't have to accept it. So these are on equal footings, and you could rearrange the order, all good stuff. So that's nice. They're on equal footing for the types, the argument types and the return type. So they have the overall type is the same between all those functions, which is a good sign that you have a good API. Spotting these type mismatches is actually a good reason to write specs. So they make good documentation, but they're also like, oh, those are different types. That's weird. Or when you realize you have to do a bunch of ors in your types, you're like, that function is probably too complex. I'm doing something wrong. I see the same thing when writing docs. So one of the nice things about the documentation for Elixir is it's built into the code. So the @doc gets compiled into the code, sort of like doc comments in Python. But additionally, XUnit has a thing called doc test, where if you have an @doc and you have a doc string here with triple quotes, and you indent 4 spaces, and you do like a fake terminal prompt, IX, whatever, and you call first, and then you put the value underneath. Let's say first just returns 1. When you do doc test in a test module, and let's say this is in def module M. If we say doc test M, it'll go through and find all these chunks that look like code examples and actually run them as tests. So anything on lines like this, or lines that are like dot dot things, so anything that looks like a prompt, it executes this code and then asserts it's equal to the value output. So it looks like you're copying code from an IX terminal, but you can actually run these as tests. So they're documentation and they're tests. And it means your examples don't get out of date. Your comment, you know that whole problem where people say they hate comments because they are always out of date? Yeah, they don't have to be. So this with is great, but it really only handles the success case because all your errors are just piling out here. So like, if first returns an error, it skips this part, falls out. If second returns an error, it falls out over here. So then whatever this with block is returning to, it has to handle all your error cases now. Sometimes that's good. So right now, this is a happy path only, which is a great way to look at it. But that means all your error cases have to be handled somewhere else. Sometimes that's okay. Sometimes it's not. Sometimes you want your errors, you want your happy path easy to view as a path. But you want your error path localized too to this code because of context and keep in your head. So in a later version, they added an else to the with. So then you can do error, not found. So you can match an error and do your error handling here if you want to. I haven't used the else format of with that much yet. Most of my error handling, the way I do it, is the function, either the functions themselves, like for plug stuff, format the error for the plug and call halt, and the happy path is just there. And then for the other cases, I just do this sort of with, and the upper cases handle the errors. And the reason for that is like, the error needs to be formatted for the interface I'm going to. So whether I'm talking to RPC or to API, that's where it has to decide how to do the errors. For a very specific reason, in our cases, we use JSONRPC, and it actually says like, if the ID you pass it is wrong, you have to say param invalid at the JSONRPC level, but also the JSON API level of like, this JSON path is wrong. So like, we have to keep them, how you format the errors are not transport agnostic, so that we give the errors to the end. And the success case is like formatting like maps in a JSON string, so that can happen at a low level. So that's with. I don't use for that often for the specific case I called out in the slides. In that there's times when I'm going to use for because I don't have to write as much code, and then I forget a case, and it just silently doesn't return anything, and you just get an empty map. There is one place where I've used a for as a way to do filtering faster, where I want to match if a param matched a string value. And so let me see if I can find the code. Here we go. Okay, so right there, I'm getting all the fields from the XO schema module. This will become a list. I'm looking at each of those fields. Those will be atoms because the way the field names work on structs. But I need to turn them into a string to be like, okay, is it a string? And then do they match? And the reason for this is this way, in case the struct isn't loaded, if the struct isn't loaded until right when this code happens, doing string to existing atom might fail because the atom has never been loaded yet. And so this way it gets around that whole problem of having to worry that the atom hasn't been loaded yet by the time you try to use the code. It's a weird race condition, but it happened to me a lot during tests. I'm like, whatever, fine, I won't use string to existing atom. And so we're doing it just like with, we can do a matching clause to be like, okay, take whatever. We have to generate something. So like, there's no pattern here, it's just give me the value. Then we can do equals where we're just trying to get some local variables. And then we can do a filter clause with booleans also in for, and then like, okay, there's potential field. But this can fail, but it's a for. So like fors never fail unless you, what happens instead is you just get an empty list. So then I match on that. Be like, you got a field. Yeah, that's the field. You got nothing. It ain't there. So that's like my fanciest for, and it's for such a weird reason.
So I have a question about the driver for this. So can you, so I thought when you did atom to string, if there was an existing...
Atom to string is
No,
the other way.
sorry, yeah, string to atom.
So
Like,
there was some
it
weird
would match the
cases.
symbol table.
There was some weird cases where for some reason the struct wasn't loaded when I tried to do that, and it would blow up as like the atom does not exist. And for some reason doing it this way, where I request the fields from the struct first and then match them, it works. I don't know why. I would think it would be defined because like they're passing me the module name. So it should be loaded. The only thing I can think of is because now that I think about, now that I said that, I do know why it is. Because when you pass in the module, it is just an atom, or an alias, which is an alias to a longer atom. So just to cover in case people, why do we call module names aliases, is because when I say def module enum do, and this is an alias, it's an alias to a much longer alias, elixir.enum, which is an alias to the atom of the same spelling. So aliases are aliases to atoms. And so when this gets passed in, it is like a literal atom. So it doesn't, that reference to the atom doesn't load the code. And so if there was no other reason to load that module in memory yet, during like development and test, then the code string to existing atom wouldn't see the fields. Because the fields are only loaded when you actually when you load the module into memory. And that's what this is for. There'd probably be a way to be like, I could probably also do code ensure loaded and then do a string to existing atom. But this way worked, and string to existing atom also, I think, throws an actual exception if the atom isn't there, so you have to do a try around it. And so this way, I don't have to do a try around it either. So I kind of like that about it. Anything else that I just glossed over that people didn't get? I went through for and with really fast. Yeah.
Well, so to kind of return to my original question, like if you're not using like a real functional language, what is the real advantage of pattern matching? I mean,
pattern matching for me is you can dig down quickly into the structure without having to have separate lines for each part you're pulling out. And so it's useful that way. And the other thing would be is like, you would have to pull out each into a local variable, and then do an if on those parts, do an else on the other part. And so, yes, you have as many branches, but the branches aren't as compact visually, and that matters for the amount of like things you can keep in your head. Like it needs to be on screen for you to easily, as a programmer, keep in your head. So the fact that like it can be more compactly represented matters for you to be able to hold in your head and reason about it. And so yeah, like of course you can do everything that under the covers the compiler's doing. Like every case statement with a tuple is like there's first an is tuple check buried under the covers there, in the actual code that's running. And then after that there's the is it a tuple of this? Okay, it's a tuple. Then you check the length. Then you start checking the components of the tuple. And you could do all those in if, but that's all nested. So like that first. I'm just never going to run on these things. Cool. So let's say our case of first. So you're first going to do like first you do an is tuple check. Then, I mean, it doesn't really matter because they're the same size, but the case you wouldn't have to do it this way. 2, you're like tuple size equals 2. Then the next one is like is lm 0 equal to okay. Then great, you're in this form. So like, you would have to do these as separate ifs on different lines, or you'd have to do the compact and thing like you would in like embedded C, where you're like, here's all these conditions, roll them all together. While this like visually you can see that, and you don't have to really think about this in your head. You don't have to read all these checks over and over again. Like it's just like, is the data this shape? And I find that easier to reason about than all those separate checks. Is it a tuple? Is it a tuple? Is it the right size? Because like tuple size is both like, it'll error if it's not a tuple. So like you're both doing an is tuple check, and you're doing a tuple check again, and then checking its size. So that's why it's just a more compact way to branch than a bunch of ifs. And it also allows you to keep the tests more flat than having to nest these or do the and.
Cool.
The destructuring is highly cool too, because you can, the way I think about it is there's like this, you're saying to dig down into it, there's this sort of mask of a data shape that you want to bind, and it's got these characteristics, and you can just apply that to the data, and those things just materialize into scope, and then you can go to town on it. That's so much boilerplate that you don't even have to think about or deal with, to get that done.
Yeah. I definitely say that being able to pull out both pieces can be really convenient. Like, yeah, you could do this in 2 lines with like both, say R is the value, like at this stage, and then grab value down here. But like it's all these checks, and then you grab all the values. And so the problem is, if these are a bunch of ifs, Java style, you're going to go R equals first, like if is tuple R, and then you're going to do if tuple size of R equals 2. And I'm not doing and just for the sake of like, say there was places that made sense with the other steps. And then, okay, we get a tuple size of 2. Then we do, well, we need to say R1 is element of R0. Okay, we got that. So if R1 equals, okay, so we can do that. Then finally, we can say value, ran out of space, that's not a good sign. Value equals LMR, comma 1. Okay, so we have that. We have all these temporary variables cluttered up are like, so if the variables, even if the variables are highlighted, in a different color, if I make them stick out, R1, value, R, So we got our ID, we got syntax highlighting. The thing is, here, the only value we cared about was value. That's the only one that's going to be syntax highlighted. Or like R will be. So we get 2 that your brain picks out on that line. Here,
do that.
Here you got this R, you got this usage. Okay, maybe your ID's nice and it reads our different color or something. It's underlined, so it's a read. So you kind of see it's different. But otherwise, you've got this R, you got value down here, you got this R1 in between that your brain has to be like, I actually don't care about that, I'm done with it now. And so this way, there's less visual clutter for your mind to keep track of. Like, it's one of those things of like, you're telling, it's sort of the argument they use with Haskell, like, you're telling it what you want to happen, not how it happens. This is very imperative of like, this is how I want you to do the check.
But you're gonna end up modeling this in a completely different way in a language like Java.
Yeah.
Because suddenly you're gonna have the a success subclass, and you're gonna have a failure subclass, and this is gonna be spread over 6 files.
Yeah. So it's somewhat disingenuous of like, yeah, you could hide this all in a bunch of methods, and then you could, but you would need a special. you would have to have this class, this tuple would be like an is okay tuple.
Oh, yeah.
And then you'd have to
It would
have
be
a thing to
something.
get value. It might be that you would, well, it's a tuple, but you don't know it's okay tuple. Okay tuple is a subclass. You have to get a method. So like everything is doable, and like there's even functional stuff like, you know, the IntelliJ IDE plugin is in Java, but the JetBrains guys, because you know they actually like other programming languages, they actually have a pair type, and I use it all the time.
Sure.
So it's super useful to have a pair type that is a 2-tuple. But there's still caveats of, like, there's way more local variables that you don't actually care about, but that need to be there to do the little checks. And so it's nice not to have that, because like this checks for some of the cases in my code where like it takes up one line, and I understand that I can describe what it's doing is off screen in a more explicit imperative language. And I don't think this hides anything. You know, because Elixir,
I'm totally
Elixir,
agreeing with you here.
yeah, Elixir. Well, I'm talking to everyone. Elixir is, you know, all about being more explicit than like Ruby and the language we came from. But I don't feel like this sort of explicitness is better than this. I mean, maybe sometimes you have to think about this, and that's kind of the thing where I was talking about. So that's a good reasoning of why do you not repeat and why do you get subpatterns is like, when you have to think too much of how this pattern, if it's super big, is branching in your head, make it smaller. Be like, I'm going to take out this value. This value is actually a struct, and like it's nested. Like, fine, pull it out, because it's too hard to describe what it is. It's sort of like, if you can't document it, then it's not good. You know, if it's too hard to explain how it is, or it's too hard to set up a test to show what it is, all those ways of documenting what it is, then yeah, don't put in code that way. Because like, great, it's super impressive. You made a really long nested map. But like, if it, I guess just from a formatting perspective, if I have nested maps or nested structs, I try to put them on multiple lines. So then you end up getting a really long line, because I don't want my brain to be confused about the matching of the braces if they're all in one line. And so then I do multiple lines. Well, then you have the problem of it's too many lines for you to read and reason about. And so that's sort of a call of like the reason of, oh, this is too big of a pattern. Of I'm too far down to show this. Okay, any other questions? Okay. So we have the room until 9. We can cover anything else. You can have questions not about pattern matching. You can have just general questions, and I will answer them if you have any about anything on Elixir.
Well, kind of to follow up on something you said at the beginning, like, do you think there's any chance that this pattern matching, this type of pattern matching will show up in more imperative languages, or why hasn't it?
Yeah, it has in some. Mostly, so the thing is that pattern matching requires structural typing for the most part. Where like, if you have the same fields, I'm going to assume you're the same thing. That's not always true, but it's really helpful. And so you kind of have to be in a language where you build up all your types from those primitives. So like that's the case with Clojure, and that's the case with Elixir and Erlang, where like, I'm going to build up my type from maps. Sure, I have structs, and it's a named map, but it's still a map underneath. And so I can match on it as a map when I want to. But if all your patterns need to be like, I need that specific class to open it up, it makes it harder to write generic code that handles that matching. And so it's very hard to do that. It's not to say it's not possible, because, well, the thing is like, Haskell has type classes, and you can just define aware of like, kind of say equivalencies of like, I have this shape, here I'll prove it to you. And so you would need that in a more mutable language, where like class hierarchy is more important. But yeah, you really need to be able to do structural equivalency. And a lot of languages, like you have to define equality, there is no structural equivalency. And so I want to say that when C# brought in pattern matching support from F#, they added like a new method that does the structural equalityness. And by default, it makes sense and it acts the way F# does. But like it's kind of like a parallel track to the equals. You know, because like the example would be in Ruby and Rails, active record equality is ID equality, meaning like you have the same row in the database. This can cause some issues sometimes, but it's nice for like I didn't load the same amount of stuff, but I want you to still be equal. But in Elixir, the equality would be an ecto schema structs and there's structs, so it's still just structure equality. But you can't do equality of like this thing in memory before I put it into the database is going to be the same thing as what you have in memory now, because it's going to do it by equality. So you have to do structure equality manually if you're trying to do like batch processing in Ruby and you don't want to do a pull from the database first. And so it's possible, but it's a shift in how people write the libraries to use the structural equality checks instead of the equals method that a lot of stuff would have, which usually isn't structural.
Cool.
Yeah, I mean, it's tough with the object-oriented languages because they have this notion of like, you know, built-in defaults for equality that are like hash code or
Yeah.
you know, whatever the reference. of the
I could
object
kind of
is.
see the argument for Ruby in the argument that it's like a duck type of like, I have these fields, and some sort of new sigil means like, you have these fields. I don't care what they are, but like you have these attributes. So I could see that working, and I could see it working in Java either by reflection of you have fields of a certain type, or like they kind of have this for like the Java Beans system of like you have fields of like certain accessibility modifiers and certain naming scheme, and therefore we know how to deserialize and serialize you, and therefore we could do structural equality on you. So I can see ways in the other ecosystems to do it. It would just be a large shift where the community would have to get used to doing it for it to take off. But yeah, of course they could do the shift.
The cost has always been prohibitive to, you know, pay for the syntactic sugar
Yeah.
with things like reflection.
So the thing with Ruby where you could do it is, in the reason why you can do regex in a case statement in Ruby is because they don't use equals, they use 3-quols for that thing, and that's why you can be like an instance case the class name, and that works because that's using 3-quols. So if you wanted, you could make a new class with 3-quols that allows you to do structure pattern matching. I want to say someone did it already. But the thing is, like, you have to worry about like it working both directions then, and like there's no, I think there might be a way in Python, but I don't think there's a way in Ruby to be like, no, when you do this operator, you have to call me first, because like my version is the more important one and the other guy doesn't know about me. So like that would be an issue of like using something as a pattern or using something to match that pattern works. Like structural equality, you don't, like there's some caveats with maps with like, I don't care about these keys, but in general you kind of want it to work in either direction equivalently, and that I can see it working. Maybe it's even possible with 3-quols to make it work in Ruby the way it is now, but it's mostly a thing of adoption. So the Ruby, from what I've seen of talks at European conferences, the Ruby community in Europe is different than the community here in America. The American community is dominated by the Rails way. And so like there is experimentation of, you know, ways to do more functional Ruby and, you know, more immutable Ruby where they would be able to go multi-core easier. It's mostly a matter of like MRI has to support everyone. It can't support that immutable subset that will work really well for multi-core. And so there's always going to be that problem of like being able to serve both bases. And like that's been one of the things with the JIT is like the JIT would add startup time. No one's found a fast way to do fast startup JIT. There's some like, you know, like there's 3-level JIT in browsers for like JavaScript, but it requires a lot of control and a lot of work and a lot of resources to make a VM work that way. And unfortunately, our programming languages just aren't funded that way anymore. Like we don't buy the good compilers from Pascal anymore, you know? Turbo Ruby doesn't exist. And so you need academics with good funding, and like Oracle gives that to the JVM. That's why the JVM still is awesome. But even with that funding, they never really had great startup time. Like maybe they'll get it now. But like think about that, they've had funding since the 90s, and some of the research in there happened, I think, pre-90s even, that went into the JVM, and so for Hotspot, and so it's like, it's going to take a lot of work for every language to be able to have, you know, all the features like that. Because someone has to be an expert in another language to be like, I know how to port that feature, and I know how to make it work in our current ecosystem. And so languages, yes, Turing completeness exists. Technically, Turing completeness works on an infinite tape, and no one has an infinite tape, so just because everything is equivalent doesn't mean in practice it can be equivalent. Or you can implement every feature and have it actually work, because you have the ecosystem effect. The ecosystem effect makes Ruby really easy to use for fast setup because everyone's made a gem for it, it's very popular. But it also means that certain features can't go in because of that popularity, because the libraries just aren't written to handle that. And so like I would say, like, don't think you're going to switch from Ruby to Elixir. No, just get used to the fact that like there will be specializations for each use case. There will be specializations for each language. And I don't know, that was my experience. Like don't think that like you're ascending this hill of like this language is better for programming. No, they each have a use. They each have their caveats. And we can't expect every feature to be in every language because they just won't work well cohesively as like not just a programming language, but as like an ecosystem to program in and to have useful packages and to actually get work done doesn't work if they all have all the features.
Well, like anything else, it's the use case. I mean, the Java use case is, I'm gonna go do a bunch of stuff.
Yeah.
So therefore, if it takes me a little while to get started up, that's okay.
Yeah, like I'm going to have that server running forever, but Ruby wants you to be able to script with it, which means you need it to be able to start quickly, and no one's figured that out yet of a way to do it. Well, okay, you can do it with a lot more memory, but there's also that thing of like, it's a scripting language. We don't want to eat a gig of memory. People will freak out if your tiny little command line script eats a gig of memory. And so there's that balance too. Like you can, you know, trade space for speed. And so you could have more stuff, you know, pre-JITted and, you know, write out the pre-compiled files the way Python does, that sort of thing, and the POs and PYOs and stuff like that. But it's always a balance between all the use cases people want for different languages. And Java's okay with the startup time because it didn't have to be that fast when it was applets, because you had to go to the website anyway, and the website had to load, and everything was slow. And for servers, you want the JIT if it needs it for hotspot, but like you're okay with it being slow on boot. But you're not okay with command line tools being slow on boot. Because maybe they're a command line tool that you don't drop into a shell. You keep starting and stopping them over and over again. It's sort of like the debate between like people that use Vim sometimes are like, I hate the IDE, it takes forever to start up. And I'm like, yeah, but my IDE has been running as long as my laptop's been on. I guess I just don't shut it down. It's a different way of using tools. And so like the arguments sometimes don't port between languages and they don't port between tools because using the tool in that way is just not the way that people use it in the community, so it's not really an issue. I do restart my IDE a lot, but that's because I always run in debug mode because I'm constantly developing it, but that's a different problem. Anything else?
So, is there some particular argument that you can make that would make me want to switch to using your plugin as opposed to like Emacs?
I haven't used Emacs, so I'm not sure.
What's like the top 3 killer features?
So as far as I know, mine is the only one with the proper grammar. Like, my grammar is correct to the point of it found bugs in the original grammar, because I tested mine because I didn't believe I understood their grammar, and I didn't believe I understood how to use my grammar generator. But what that means is, like, a lot of the grammars in Vim and Emacs they're like one level deep of like interpolation. Like you can have one level of interpolation and it'll work. Which means like there's edge cases because they're using regular expressions to match what a proper grammar is. It also means that like I'm pretty sure in Vim and Emacs they're treating def module like it's a keyword. It's not.
It's a macro.
It's a macro. And so my plugin, especially in the version I'm developing, it can actually jump to the decompiled version of the beam and show you def module. And you can go to it, and it's real, and it doesn't treat it. And so the reason why this is nice is the ones that treated def module as keywords will have a harder time adapting to new DSLs that stuff may produce. Like XUnit code, just works. Property test code, DSL that Dave Thomas invented and showed at Lonestar.RB, it just works. It's parsable because it's still valid Elixir syntax, even if it's not the way people write Elixir in the standard library. Like, it is valid code. So like the grammar supports more syntax than people are currently using. And my grammar supports that too. While in the other IDEs, they don't. So like you'll have to wait for an update for like your library you like to use to work. The other thing would be is, like all IntelliJ IDEs, once it builds the index, it's cached. So that might be the case with the Elixir stuff, like if you use some CTAKE equipment where it writes to disk. But that's just how IntelliJ stuff works, is like they generate this thing called a stub index. So like when you do, go to symbol, it just knows it's there and can look it up quickly. There's a little bit of refactoring. I don't know if the Emacs plugin has that. So like you can refactor locals, and do renames. So
across modules?
Not yet.
Okay.
Because that would be like function name renaming, and I haven't done that yet. But I can do locals, so like I think this should work. Oh right, it won't work because 4 is a special form. So like it doesn't know that these are supposed to be the same, but it knows those are because it knows that those are literally the same. So like.
What about...
so it can change those combined.
Oh, okay, right on. What about for EXS files? Does it work the same?
Yeah, it's the same grammar, it doesn't care.
Okay.
It doesn't support, it supports EXS because it treats them in the same grammar. It doesn't support EEX yet, mostly because support for embedded languages is part of the closed source part of IntelliJ. So I've kind of gotten tips from JetBrains of how to do it, but like I can't look at RubyMind's code to be like, how did you do ERB? I don't know that. It seems mostly like it's a super grammar, and then like they kind of have like, if you happen to be in ERB, right here, you could go switch to the other language. And I haven't attempted to do that yet because I can't look at another open source plugin and be like, oh, that's how you do it.
Okay, that's cool. I may have mentioned to you there's a guy on my team that uses IntelliJ. I've got a mixture of like Emacs, Atom, and one IntelliJ guy.
Yeah, and I will say the JetBrains IDEs support both Emacs and Vim key bindings. I'm using Idea Vim, which is one of the plugins that JetBrains maintains for Vim key bindings. So you can have your key bindings if you want. It's mostly, stay in Vim if you have a bunch of Vim plugins you like, because this isn't going to be able to use your Vim plugins. It just has the key bindings that everyone's used to.
I have a question.
There is now mix integration though, so you can do mix, and you can do. Let me see if I can pull up a test. It does have support now. So just recently added a new full-time contributor. He added support for mix, and he's adding support to get the early Burley debugger working. So you'll have graphical debugging in this once I land the PR. So you'll be able to put a breakpoint in a line and like debug the code normal style and not have to do price style debugging. And that was actually one of the main reasons why I started it. Was I love graphical debugging. I loved it in Eclipse. I loved it in NetBeans. I just find it easier than having to change my code and restart, to be able to like, I get to this breakpoint like, oh, I want my breakpoint down there in that line, but, and I like the state I have right now. And so it's nice to be able to put a point right there or do run to cursor, and it can do that. And also the fact I just find graphically being able to like unfold the structure to be easier than to like pretty print it and then visually have to be like, oh, I cared about this nested thing here, I want that collapsed. And so that would be the thing I really like, but I still have to merge the PI.
That will be awesome.
Yeah. So the big thing for 5 is that decompilation will work, which means you can jump to the decompiled version of any of the beams in the Elixir sound library, and I'm going to also add support for the Erlang sound library, which means instead of like hard coding the functions in kernel, which is how the earlier versions did, to be like, oh, this is a predefined, because people complained that I wasn't highlighting def module as a keyword, so I did a compromise of there's a predefined color to be like, it looks like a keyword now. And so what I'll do instead of be like, if it is literally defined in kernel, it'll do it that color now, and because it can do a reference and jump you there to do it. So a lot of big things in 5. But right now, like you get mix, you can right click anywhere in it. So you sort of like remind, like you can right click in a test and it'll run that test. Well, run that line. You can right click on a file or run that file. You right click a directory. It allows you to run the entire directory as tests.
I guess you have a built-in REPL as well.
No, we don't have an IEX REPL yet. It's more, I guess I always use terminal, like the terminal that's built into the JetBrains IDEs now. I don't have the REPL built in yet. But mostly the nice part about that is the JetBrains like hyperlink formatter is built in when you run the test. So like if you have a stack trace, it recognizes because one of the contributors wrote the thing, but it can parse the stack trace and be like, oh, click it and it'll jump to your code, which is nice. And like, because it's a graphical IDE, like you expect that. While I don't know if Vim when run in GVim or if Emacs when run in graphical mode has those sort of features, but like that's a nice thing about having the graphical one too, is like you have those graphical features to jump for you.
That's cool, man. Yeah, no, I spent a lot of time in it doing Java work, so
Yeah.
these features that you're talking about would, I think, be worth it.
Mm-hmm. Yeah, the main hairy point with it is, now that I have jumped to def module is, so if you think about it, when you do def module, or when you do def foo, both the def and like the entire def foo do, like def foo do as a whole call is defining foo, but that def you also want to be able to jump to because you want to go to the macro that defines def. And so like that's a little hinky with the way it works, because it counts the entire call as like one AST node. So like I'm working on that because I keep getting stack overflows because it loops accidentally. But yeah, once that all works, it'll be pretty cool. We'll have decompiling and we'll have debugger.
Nice.
Okay, it is 8:30. We have like 29 more minutes if anyone wants to continue. We also, usually afterwards, because they kick us out, but we can just go there now, is we go to one of the local bars just to drink and continue talking about general nerdy shit. Oh yes, we are looking for sponsors. We have yet to convince a company to buy us booze.
Okay.
So Luke, has anyone given a talk on metaprogramming recently or lately? Or
I don't. Like, even pattern matching, we've only covered pattern matching because we covered parts of Learn Elixir in Action. But, I would really like the format to be like, first talk is more like a fundamentals talk or beginner talk to attract new people. And then like the second talk of the night, sort of like Austin.RB, is like a more whatever talk, either more expert talk or a more esoteric talk or like a specific library talk, that sort of thing is what we're going for. I'm giving this talk because I couldn't find anyone else to talk. So we are always looking for volunteers. But yeah, I can't recall us having a macro talk in a while, so like, do you want it as a topic or do you want to give it?
I'm not sure I'm qualified to give it. I'm digging into this stuff now because I'm doing some stuff where I have to have access to the compiler at runtime for hot patching and stuff like that. But
the best way to learn something is to teach.
Yeah, so the meetup is always on the third Monday of the month. If you want to, you can say you're going to do it and bail if you want. I mean, you don't have to be that good. We're all not that good. Like, you're good at it because you talk about it and you learn enough to talk about it so you don't sound like an idiot. Like,
yeah.
it'll work out. Don't worry about it.
We won't throw fruits in.
All right. Well, we'll talk about it. I finish my project first, and see. Then I'll have some code we can look at.
I mean, we can also just give talks on like, at the thing I do during work, I open source some library. You can do those too because, I mean, people do package talks all the time at Ruby meetups. Like, mostly because like you have to know about the ecosystem. Like, people aren't going to go through and look at Hex PM and be like, oh yeah, that looks interesting, that looks interesting. Like, you need to have someone tell you about it and how to use it more than the README, because usually the READMEs aren't that great.
I'll tell you something. I've been plumbing the depths of the built-in console logger and reading Jose's code of how that thing works. And because there's this thing that's built in called capture log, exunit.capture log, and there's capture.io. And there are these situations where, like, first of all, the basic console logger is really impoverished, I think. It's got like, a couple of metadata fields and a string, a message. Like, have fun, go to town. And it's so annoying because
have you checked in 1.4 if it got better? Because that's when they add the automatic colorizations. So is that part console logger too, or just for IX?
Well, you're thinking about like specifying ANSI color. Yeah. I think that was in 1.3 because I read both code bases.
Okay.
But they did change it in 1.4. There's this new proxying thing where basically they start up you can basically capture all the standard error from the logger in an Elixir unit test, and then run assertions on top of that, which is a way to kind of get an indication of state of what line of code you're on and where you're at and which branch of logic you fell through and stuff like that indirectly. But I think the problem with the built-in console logger is that because things like maps don't implement string.cars, and process doesn't implement string.cars, and you're always like inspect this, inspect that, and you're doing all this like wonky string interpolation, just to see what's going on with a lot of your code. When you should just be able to like put a bunch of metadata keys on the back of it, which are just field names, and then have those sort of pre-printed out and not blow up for you.
I'm trying to think. I could have swore our console logger has the user. Oh no, I know what's happening. So that's right, because logger just has the metadata function, and we're literally putting user ID. We're not putting the user struct and having it inspect. We're literally putting user ID, and that's what we're doing. That's right.
And then if you're going to write other backends, like like I use Elasticsearch as one of my backends, and I want like discrete fields on all the things that I'm interested in. And
well, you can do logger metadata. You just have to have your consumer for the logger pull those metadata fields back out.
Yeah. But in any case, capturing standard error in Elixir is not as straightforward as you might think, especially because the logger is like one of the things I discovered is that if you're just using like io.puts, inside of your own custom backends. Apparently, like puts is async when it writes to the console, so that there's no guarantee that it will have output to standard error by the time you run assertions when you're trying to capture that thing.
I have had that where I try to check the log messages for like reconnect. I use the connection behavior for like our RPC stuff, and the tests are super flaky because like it'll run the test and be like, assert failed, and like you see, as soon as it said assert failed, like you see the log message I was trying to capture print out. I'm like, fucking.
Yeah. Anyway, so they do some funny stuff inside of the console logger. They're not just doing puts. They've actually got like a couple of different processes that, one that's generating the stuff and buffering it, and the other that's actually, outputting it, and there's a flush command.
Can you make it unbuffered? So it
Yeah,
immediately goes-
yeah. Well, that's you can set the buffer size to like 0, and it won't buffer, or you can call flush on theirs, which will dump it out, and then you can run assertions against it.
I'll really try the flush trick. Maybe that would make the test less flaky, since it always seems to print immediately after printing that the assert failed. I wonder if a flush would be enough to fix it.
Anyway, what I found when I looked at their capture.log is that it's hard-coded to look for a process called :console, which is the name of their logger backend. And so if you want to use your own logger backend, you're SOL.
Oh, that's right. I remember having to do that because I took it out for tests and I'm like, oh, it doesn't work. Okay, put it back in.
So what I figured out though is that you can just grab those, for whatever version of Elixir that you're using, you can just grab those files and monkey with them and then make them part of your project. And so I've got a project that's like my logging backends and stuff, and they'll just like overwrite.
Yeah, you'll get the already defined in memory warning, but that's about it.
Yeah. Anyway, yeah, I've been hacking around a little bit trying to get some of these things that I think are conveniences that I've been missing, in Elixir. I realize like it's a pretty young language just because, someone else hasn't done this better already. But there's a lot of activity on the mailing list where people are asking Jose about this kind of stuff, and he's like, yeah, but I don't want it in the standard library.
Yeah, that's always kind of.
Anyway.
I mean, that's why I got my standard library contribution was I was reading Dave Thomas's book, and I'm like, I wouldn't solve this with sort. I'd solve this by sort by. Where is sort by? Huh? It's not there. Well, let's ask the man. They're like, yeah, you can add it, whatever. Okay, like that's how it's in there.
Oh, nice.
That's how I got sort by. But it is super cryptic because I'm looking at the other code and like it's using a bunch of like captures with like and one, and I would never write it that way now, but like that's how the rest of the code is written. So I'm like, that must be idiomatic, so I'll write it that way. But it's like 4 lines to like do the Schwarzschild transform to like pivot the tuple in and out to like get the sort by key working with sort, but it was weird.
Good, thanks.
Thank you very much.
So does Echo do like monkey business like active record where it like interrogates the schema and generates method accessors, like data accessors?
No, because they're just